Slide to the left. Slide to the right. Crisscross. Crisscross. Everybody clap your hands. All right, I'll stop. But that is a great song to dance to. And it's not only a great song to dance to, it's a great song for our lesson today. We're in level 2 here of our geometry boot camp, and our level 2 lesson is on translations in the coordinate plane. There's our lesson right there. There's a good title for your notes. 2 learning targets. Number 1 would be just transforming figures by using translations. So very simply understanding what a translation is. And then the main one for today is number 2, transform figures on a coordinate plane by using translations. So a couple things will help you be successful today. 1, being able to plot points on a graph. So having an X and a Y. And remember, the X tells you to go left or right, positive or negative. The Y tells you to go up or down. Oh, there's my arrow. All right, second one, translation. It just means to slide in one direction. As long as you know that, that'll help. And then translation rules. So we're going to talk about those a little bit today as well. Before we get started too much, a couple vocabulary words. One is just what a transformation is. Since this is the first lesson on transformations. A transformation is a movement of geometric figures. Okay? Some sort of movement. 2 other ones that are going to help us today. Pre-image. When we talk about pre-image, that's the position that a shape or a figure or a point starts in before you do a transformation. So pre means before. So think about that word pre-image, meaning before you do something to it. And then the image, well, it sounds like it should be post-image, but it's just the image, is the position that it would be after a transformation. All right? If you need to pause it to write those down, feel free to do so. You should have vocabulary in your notes. Let's go to the main vocab word, which is right here. A translation. Not translation of Spanish to English. A translation in math is simply a figure being slid in any direction. So for instance, we start with this figure right here. I'm just outlining it for you. And if you slide it over to the right, it ends up here. Your transformation, what happened was you just moved it, you slid it to the right. That is a translation. We're going to specifically work on this with a coordinate graph. So here's our starting example for translation. It says to translate a point by an ordered pair, A, B, add A to X coordinate and B to the Y coordinate. So we're going to talk about what that means. Let's start with a point 2, 3. 2, 3, right here. It's in red. I'll put it in blue, but it's right there. If we were to move, let's just translate it 2 to the right. If we were to move it 2 to the right. On a graph, you can physically move it 2 to the right and count 1, 2. And our new point right there would be right there. Now, a lot of times, you'll see a point is labeled X or A or something along those lines. When you move it and when it gets to its final destination, it is now called X prime. So that little apostrophe is called a prime symbol. Think of Optimus Prime from the Transformers. It's just showing that it's the second one. It's not the same as X. It's moved now. Now it's X prime. And now the coordinate, it's not 2, -3 anymore. Now it's 1, 2, 3, 4, -3. And maybe you notice the -3 did not change. So the Y value did not change, but the X value went up by 2. So that gets into our first rule. So for translation rules, you can always do it on a graph, and these are shortcuts you can do without a graph. So moving to the right, and I would actually copy down this chart. This is an important chart to copy down. Moving to the right, you add to the X coordinate. Okay? So if I knew I'm moving 2 to the right, all I had to do was look at the coordinate, add 2 to the X, and I'd have the new point. Without even graphing it, I would know that. So our example, translate to right, we would go from XY to X plus 2, and the Y stays the same. And that's the example that I just did at the top there. Okay? So it became 2 plus 2, which was 4. Let's talk about left. You think left, you think opposite of right. So we're starting with our x at 2, -3. And for this one, let's do 6 left. Well, I can count 1, 2, 3, 4, 5, 6. There's my new point. That's my x prime now. And the coordinate now is -1, 2, 3, 4, and -3. So you may notice that, again, the y value stayed the same, but the x went down 6. So if you're moving to the left, you subtract from the x coordinate. You're going towards the negatives, you subtract. So translating 6 left, it would affect it would go from the point x, y, whatever it is, to x -6, and the y stays the same. Now you may be able to guess for the y, or for the up and down translations, the up and down axis is the y-axis. So it's going to be a little bit different than what we were just doing. Let's take an example, 5 up. So for 5 up, I'm just going to move it 1, 2, 3, 4, 5 up, and there's my new point. There's x prime. X prime now is 2 and 2. So this time the x coordinate did not change. So when you move up, just like when you're graphing it, the y coordinate, it's up and down. When you move up, it affects the y coordinate. So we added 5 to the y coordinate. So if our example, so again, adding to the y coordinate would be going up. That's for up. And adding 5, or going up 5 would be, the x does not change, but the y goes up by 5. And last one, down. So let's just say we're going down 1. Same thing on a graph. You can always graph it. If you don't have graph paper, there are shortcuts. Going down 1, I can simply go down 1 from that point, and there's my new coordinate. And now it's 2, -4. So down 1 would be now 2, -4. And you see it only impacted the y coordinate and made the y coordinate go down 1. So going down, you would subtract from the y coordinate. So if I'm going down 1, the x isn't changed, but it's just y -1. So those are all rules that you should have in your notes. Those are rules that you hopefully will get used to the more we do. And we're going to practice that with a few examples now. All right, translation. Here's an example of translating a whole shape. So the shape you can see starts with this shape. It's A, B, C. And then you'll notice it goes to A prime, B prime, C prime. So those little prime symbols mean that this is the second shape. So pre-image. And this is the image. That's what it ends up with. All right, so to do this, if you wanted to go 6 units to the right, so remember 6 units to the right always just affects the x coordinate, so the y's are going to stay where they are. It's not going up or down anywhere. So to find point A, count 6 units to the right. You can simply do that for graphing it. B, 6 units to the right. C, 6 units to the right. They're all going 6 to the right. And that's what's highlighted in the red. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The shape should look identical, just moved. Now what we talked about was the rules and how we can do that shortcut. So here's an example. It said the coordinates of point A were -5, 4. Since we were moving to the right, we would increase the x coordinate by 6. So that's what we said before. The x would go up 6. The y would not change. So what that looks like then is we'd have -5 plus 6 would be 1. So the new coordinates are 1, 4. So if we just added 6 to this x value, leave the y value the same, it would be good. All right, we're going to do the same thing with every single point. Point B was -2, 3. And if we're moving to the right, we got to add 6 to the x. So add 6 to the x. That will get us up to 4, I believe. So we get 4, 3. And that was where we ended up. And lastly, -3, 1. Again, if we're moving to the right, we add 6 to the x coordinate. Negative 3 plus 6 is 3, so our new coordinate is 3, 1. So moving to the right or the left only affects the x. All right, let's talk about some examples, just some general examples without a graph. Not even visualizing it, just looking at a few just examples of translating. Let's see if we can do this. It says give the coordinates of each point under the given transformation. So number 1 says 13, negative 9, we want to go left 4 and up 2. So think about left. That would be the x. We would subtract 4 if we're going left. Up 2 would be adding 2 to the y, because it affects the y. That would be up, and that would be adding 2 to it. So if we do that to our translation, we'd be taking 13 minus 4, and we get 9. And we'd be taking negative 9 plus 2, and we get negative 7. Hey, there's our new coordinate. Let's try a different example. This one, it just gives us the rule. Doesn't say left or right. So you got to think. If it says our point is negative 29, negative 11, and it's under x minus 5. So simply, that just means we're going to subtract 5 from the x, minus 5. And y plus 18, we're going to add 18. But if you were to describe that rule, subtracting 5 from the x would be going left 5, and adding 18 to the y would be going up 18. So if you were on a graph, that's how you would do it. Negative 29 minus 5 is negative 34. Negative 11 plus 18 is positive 7. So there's a new coordinate. So that's how you can do it when you're given the rule as adding or subtracting from the y and x. Now it's going to be a little bit more challenging one. We're starting with negative 31, negative 15. What do you do if you're given 2 of them? So it says do this. So it's under that. That just means you're going to do that as your first transformation. And then we're going to do this. So let's do it one at a time. If I take negative 31, and I add 6. I take negative 15, and I subtract 34. That's what it's saying to do. I end up with, at first, negative 25, and that's going to be a big negative, negative 49. Then my second one, I'm going to do in green, I would subtract 3 from the x, and then I would add 6 to the y. It's just telling us what to do after that. So I would end up with negative 28 and negative 43. There is my final coordinate after a translation. Last one is kind of a challenge one here. It says, identify the translation that was applied to A to create A prime. So we're trying to figure out what we did to get from here. So from x to x, we would do what? And from y to y, we would do what? So if I would take my x and do something to it, and I would take my y and do something to it, I could write my rule. So I think you're going down. From 14 to negative 13, you'd be going down 14 to get to 0, and then down 13 more. You'd be going down 27 total. Not plus 27, down 27. From 19 to, so that's minus 27. From 19 to 40, I would be adding 21. So it would be y plus 21. In other words, you could write this as your rule, but you could also say it's 27 left, and plus 21 to the y, it would be 21 up. All right. Last example, that's the last example I want to touch on. I just want to revisit, first of all, asking you the question, what does translating a shape actually do? And would it ever change the size? Those are 2 thought questions I'd like you to think about. And then revisiting our goal and our success criteria. We can easily transform by translations just by sliding. You can do it on the graph. And then we can use those rules in number 2 on a coordinate grid to be able to do that. All right, that's all I got for you today on translations. Enjoy the rest of your day.